the whole world. Everyone else can be posting stupid. Not you. Not today. All right. So we're going to go let m equal cos theta. The reason why I don't pick x is because in the end you're going to get m equals some numbers, right? And you might think, wait a second, m, that doesn't make sense. But if you go x equals some numbers, you guys will literally box it and move on. Because you're so used to getting x equals something, okay? So I always let it be m or some crazy letter that you never ever use so that you catch yourself and be like, okay, wait, I have to go sub back in cos again, okay? So I'm going to get 3m minus 1 equals 4m. Now I need to get m by itself, so what am I going to have to do? Move the 3m by how? Subtracting it. So we got to get the m's together. So I get negative 1 equals m. And now you have to take everything in your being to not box that and move on. Because in grade 11, whenever we got something equals something, we're done, right? But remember, we don't actually even have an m in this question, do we? We have cos theta is m. So I have to go remember to put it back. So now I go cos theta equals negative 1. Where does that happen? When x equals negative 1. Where does x equal negative 1? For radians. God. Do we have any other ones? We have a whole bunch of other ones, right? Because we have coterminals. But do we have any other ones that fit? No. Could I do the 3-step rule? Could I go reference theta equals cos neg 1 of positive 1? Cast rule, get my answer. Could I do that if I forget that that's something that's on the unit circle? Sure. I can always use the 3-step. But if it's on the unit circle, it's just easier. Yeah. Yeah. Okay. What if I give you square root 2 sine x minus 1 equals 0 from negative 360 to 360? The catch with the domain you have to watch as well. Does this 360 have an equal sign? No. So if 360 was a solution, could I write it? No. You have to watch, pay attention about the equal signs, okay? So for this one, we could go let m equal sine x. Or we could just get sine x by itself. You don't need to make it be equal to m, but a lot of people like it this way better. So what do I have to do first to get m by itself?
Is x equal to theta?
X is equal to x. That's not a theta. That's an illegal use of mathematics, and I should get a ticket. But I'm the one handing out tickets, and so I'm not going to give myself one, but I'll deserve one. So what do we have to do? You're all doing it. Yeah. Yes. Add 1, square root 2, m equals a half. Then I'm going to divide by root 2. And then I need to bring my sine x back. Is 1 over root 2 on the unit circle? It actually is. 1 over root 2 is the unrationalized form of root 2 over 2. So this is actually equal to root 2 over 2. So it is on the unit circle. So we're looking where sine, Calgary Stampede, where y is equal to root 2 over 2. Anyone know? You mean quadrant 1 and 2 because it's positive? Yeah. 45 and 135. Does that fit in my domain? Yep. Totally does. Then I have to test their coterminals because I also have to go from 0 to negative 360 as well, right? So I have x equals 135. Then I'm going to subtract 360. Negative 225. Does that fit? Yep. x equals 45 minus 360, which is negative 315. Does that fit? Yep. So we actually have 4 solutions. 45, 135, negative 225, and negative 315. Sometimes if it's a numeric response, it might just ask for the number of solutions that fall between that, and you would see the answer before. Yeah?
Because it's sine x, would you put x equals or just go theta?
Why do I bring, like I just put x's the whole way, and then at the end, it's an addiction. I have an addiction. First step is denial, I'm past that. I was going to erase with this, and you would have let me. It would have been black. People need to learn to speak up at times when it's important, which would have been that. Like, I luckily did, I gotta go away. That would have been like, oh, I don't even want to think about it. I would have had a blackboard. All right. Yes, please continue to use x's the whole time when the variable's x. All right. You guys try this one. 3 sine x minus 5 equals 5 sine x minus 4. Okay, so this one, I said negative 360 less or equal to x is less than 360. See if I can keep x the whole way. Okay. And you have to go let m equal sine x because that's proper math. You can't just go m equals sine x. You have to go let m equal sine x because that's how you do math. That's how you math. So we go 3m minus 5 equals 5m minus 4. Subtract 3m. Negative 5 equals 2m minus 4. Add 4. Negative 1 equals 2m. M equals negative 1/2. And m is actually sine x. So sine x equals negative 1/2. Here and here, which is 210 and 330. And then we have to check the, I have random things going on here. And then we have to check the coterminals. So if I subtract 360 from here, I'm going to get negative 150. Does that one fit? Yep. If I subtract 360 from here, I'm going to get negative 30. Does that one fit? Yep. So it's going to be x equals, I took everything and needed to stop myself from writing the theta. 30, negative 30, negative 150, 210, and 330. Okay, what if I give you one that's not a primary trig ratio? So what if I give you one that's like not sine, cos, or tan? So say I give you cotan. Three cotan x plus 1 equals 2 plus 4 cotan x. From negative 180 to 360, not inclusive. So when we fill this one in, we're going to replace the cotans, and we're going to end up with cotan equals, right? So we're going to go let m equal cotan x. So we get 3m plus 1 equals 2 plus 4m. That's a lot like the previous one. Negative 3m. 1 equals 2 plus m. Subtract 1. Subtract 2. M equals negative 1. Which means cotan equals negative 1. What did I tell you when you get a cotan, a cosecant, or a secant? Equals answer. You flip the answer and immediately change it to tan, right? We don't keep cotan, we send it away. If we can flip answers, we can't flip angles. So we're going to get tan x equals -1, technically. Now I'm going to go through the 3 steps because often people don't spot these on your unit circle, but -1 for tan is actually on your unit circle. Just in case you don't remember. So we're going to go reference x equals tan -1 of +1, because the reference angle we use +1 for. Okay? And when we're doing these, we always do them in degrees, right? Because if they're a nice solid degree, if we do in radians, it's going to come up as a decimal. So tan to the -1 is actually 45. Why would the 45s be 1s and -1s for tan? If you look at the 45s, yeah. You're doing root 2 over 2 divided by root 2 over 2. Exactly. They have the exact same x's and y's at those spots, right? So tan is actually -1 in quadrants 2 and 4 at 45s. And it's +1 at quadrants 1 and 3 at 45s. So you don't spot it, no big deal. You do your 3 steps. You do your reference angle, then we do our cast rule. And we want when tan is negative. Tan is negative here and here. And then we just use our reference angle of 45. So this one's going to be 135 because it's 180 minus 45. And this one's going to be 315 because it's 360, sorry, minus 45. And both of those actually fit in the domain from 0 to 360, correct? And then we have to check their coterminals to see which ones will actually fit in the domain from 0 to -180. So we subtract 360. So 135 minus 360 equals -225. Does that one fit? Nope, it's too big. I have to stop at -180. And then my other one, x equals 315 minus 360, and it's -45. Does that one fit? Yeah, 0 to -180, -45 false. So x equals -45, 135, and 315. Let me get you to try this one. Root 3 secant theta plus 2 equals 0 from -pi to pi. What's -pi to pi in radian or in degrees? -180 to 180.